In this video, we are going to start how to choose right architecture for your application. Let me start with tweet from Chris Richardson. As you can see that he is pointing out there is no perfect architecture and all architecture styles are an architecture pattern and none of them better than other. Let's continue to another tweet from DHH. Here you can see that DHH and Kelsey agree with monolithic architecture is still very valid architecture in 2020s. So that means we should consider monolithic architecture as the same level with the microservice architecture when we design our applications. The main idea is here we must pick the architecture that satisfies your application's non-functional requirements like scalability, availability, and so on. Yes, everyone wants to design high scalable and high available systems, but as a software architect, you should focus on the problem and ask yourself, is it required for your application? In order to avoid unnecessary cost and resource usage and to avoid over-engineering of the problem, you can focus on the problem and ask yourself, is it required or not as a software architect? Because when you apply advanced architecture for your small problem, you did anti-pattern implementation and lose benefits of your application nature like easy to develop, debug, and deploy options and so on. So we have understand that every architecture has benefits and also drawbacks, and as a software architect we should consider every architecture with evaluating pros and cons for your project. So what is the right architecture for your application? The answer is always it depends. The reality is that the monolithic architecture and microservice architecture are architectural patterns. A pattern is a reusable solution to a problem that occurs in a context. Microservice architecture pattern is not better than monolithic architecture. Each of them has benefits and drawbacks. Which one you should choose depends on your project and the problem you have trying to solve and the non-functional requirements, utilities that you need. We should design your system with focusing on context and non-functional requirements that we also say utilities. That means availability, scalability, and so on. There is no super correct solution when we design our software, and no architecture pattern is better than other. It depends on business case and the situation of company and organization. So we should understand that every architecture approaches and design decisions comes with the benefits and also drawbacks. We will deal and compensate with drawbacks and get benefits from the advantages. So this is the wrong information. Microservices is better than monolithic. So there is no clear advantage of any architecture approaches. It always depends on your situation. Now we can learn another very important design principle, which is the design architecture for business requirements. That means every design decision must be justified by a business requirement. This is so important that and crucial when we design any architecture in order to avoid over-engineering the application architecture. As we are all engineers, we tend to be over-engineering with latest architecture styles and use latest tools and so on. But in some cases, we lost the scope of our application and it becomes an experimental application that use all latest fancy tools and architectures. And these kind of projects are mostly fail in production or before the production phase. So what we can do? First, we should clearly define our functional and non-functional requirements. After that, we should define our limits, constraints, and assumptions of the application and define business objective clearly. And make sure you understand non-functional requirements like scalability, availability, and latency. These requirements will reflect our design decisions and technology choices. And we should start and grow application with metrics. How many concurrent users that our application handle? Our application supports millions of users or a few thousands. What is the target of expected request second latency? Are there large traffic bursts or steady workloads? What level application outage is acceptable for our case? So all these questions are very important considerations before we design our architecture, and ultimately business requirements drive these design considerations. For that reason, during the course, before we design any architecture, we will always start with the problem which is the business problem that drive our design considerations. Because if there is no business problem or any problem can't relate it to business, then most probably you don't need to change your architecture. If you do, that means you are doing over engineering.